So last time we did set up the basic GLFW window and a Vulkan instance, and now let's configure some helpful debugging tools that every developer should know about and use. So there are two main things to enable and set up here, the validation layer and the debug utilities. And the validation layer, just like all the other layers, can actually be enabled outside of your application code in this Vulkan configurator tool. This basically sets up some JSONs that Vulkan will load on startup and configure the layers, or it can also dynamically apply layers to any running Vulkan executable if you want. So it's a pretty handy tool, especially when you want to switch between different validation configurations, like here, for example. And by default, it will apply the validation layer to any running Vulkan executable while the configurator is running, which is quite nice. But let's also enable the layer from our code so we don't rely on the configurator to be running for this. And this is the name of the layer that we need to enable, VK layer Chronos validation. So to do this, we just simply add this C string to the layers slice. This should already enable some validation, and we can test this by, for example, adding some extension that needs another extension to work without adding that dependency. For example, this one, Win32 surface extension name that we're gonna use later, that needs a base surface extension. Now, if we run our application, we should see an error message. And indeed, there's this validation error that complains about missing extension dependency that we will ignore for now. We just know that the validation layer is working. Now, another important debugging tool to have with Vulkan is this debug utilities extension. And this is an instance extension that provides some handy tools, for example, for naming Vulkan objects that will be displayed in all the messages and the debug tools like render, doc, and whatnot. But also it's an extension that lets you configure how the validation layer messages are displayed. And let's use that to configure the validation messages to be displayed through our Odin logger. So first we need to enable the debug utilities extension. And unlike layers, there are actually string constants in the Vulkan module for common extension names. For example, this one, ext debug util extension name, which is just a string. That's gonna be the debug utilities extension. And by the way, this ext is one of the common prefixes and also sometimes postfixes in the Vulkan API. And the ext means that it's a cross-vendor extension, so it's not specific to particular Vulkan driver, but it's not yet an official Chronos extension. An official Chronos extension would have a KHR prefix or postfix. Now, to actually configure the logging, we need to provide a debug messenger create info to the instance creation that will configure the, debug messenger for instance creation and destruction. But after that, we will also need to create a actual debug messenger object that will be used outside of the instance creation and destruction for all the validation messages that will occur while our application is running. So how do we create that? Well, it's yet another create info structure, like this one, debug utils messenger create info ext. So you see the postfix. Don't forget the s type. And this contains some fields to configure which messages do we want to see and how to log them. So there is message severity, which basically just a bit mask of the messages that we want to see. And I think we only care about warnings and errors. We don't want our console to be spammed, so let's configure that. Next is message types. Let's just have validation and performance messages. And then we have this user callback, which is a function that will be called to display the message. The type is here. Let's just copy it and create an anonymous procedure right here. Let's fix the prefixes. Now here, to use the logging, we of course need an Odin context, so let's set that up. Let's figure out the login level by checking the message severity. Something like this. Remember that the message severity is a bit mask, so we need to just check for bits. And then we can just log the message. There is more information in the message callback data that you might want to use actually, but for now let's stick with the message. And the return value for the callback is supposed to be false because any other values is reserved for the future. So now we just need to extend our instance create info with the debug messenger create info. And the debug utils extension will automatically use this configuration for the debug messenger that is used for instance creation and destruction. And as mentioned before, structure extension in Vulkan is done with a pnext pointer. So we can do it like this, pnext, just a pointer to debug messenger CI, but I actually tend to go a little bit more generic and introduce a row pointer local variable because sometimes we want to chain the pnext references, and that is actually easier when you have a handy next pointer as a variable. So let's just introduce that. Next is a row pointer, and the first assignment will be a pointer to debug messenger CI. Now we can just use next as our pnext field, just like this. Now let's trigger the validation error again by adding an extension that needs another extension, just like this, and let's see at error. So here it is, it's using the Odin logger. Now this actually contains quite a lot of garbage here. For example, this Odin source location will always be the same, because as far as I know, there is no way to pass the location information through the Vulkan debug machinery from the original call sites. So we might want to configure the logger a little bit. And we can do this with this context logger options. And there's a bunch of them. And I think we can just have a level and the terminal color. So this is a little bit cleaner. We have an error that is red, and then we have the Vulkan error message. Let's remove the test extension for now. And now we need to create a messenger that will be used for all the other validation messages outside of the instance creation and destruction. And for that, we actually need to create an actual debug messenger object. And we can do it here right after the instance creation by using this create debug utils messenger ext function. So that takes an instance, then the create info that we already have, then the allocators that we are not passing to use the default allocation, and then the pointer to the object representation, which we will store in our globals. And we store it because we want to also destroy it, right? So let's add it to the global structure, vk debug utils messenger ext, fix the argument here, that has to be a pointer of course, and we want to wrap the function in vk-check, as we normally do with most of the Vulkan procedures. Now, if we try to run this, this will actually fail, because this create debug utils messenger procedure is actually not initialized. And this is because this procedure is only initialized with this load proc addresses instance call. So let's maybe move that to create instance. Just right here, after create instance. Now, if we run the application and then close it, we will actually see that it tracks that we have created a debug messenger but never destroyed it. And this is one of the useful validation error messages. So we would need to do it here. Before we destroy the instance, we want to destroy the messenger. But since we create both the instance and the messenger in the same function, maybe it makes sense to have a destroy instance function that will have destroy instance Vulkan call, as well as the destroy debug messenger call in it, right? So let's do that. So we call the function here, move the destroy instance here, and add the debug utils messenger destroy function here. That takes the instance, the messenger handle, and the allocators that were used in the create function. And note that the destroy functions normally do not return the result, so you don't need to do additional checks here. Now if we run the application, close it, we have no errors. And with that, we are set for success for actually accessing the GPU, which we'll start doing next. But for now, stay tuned.